Thanks, and hello everyone. I'm Daniel, this is Michael.
Hi.
And yeah, about this talk, I guess you're all familiar with a series of talks given by Volker during the recent years, where he's telling about his mission, and probably those of several others here, to establish SMB as a competitor or as a complete replacement for NFS. For the Linux client, and he's mainly working towards this goal in terms of current lack of file system features to make it to make POSIX extensions being up to par with what NFS can provide, and this is sort of complementary. This talk is complementary to his work because we're both ops guys, not developers, and we've taken a look at this by seeing, yeah, what actually happens if we take it for granted using SMB as an NFS replacement on Linux, and which other non-functional problems do all arise if you just go ahead and try this. And as it happens, if you go ahead and just take a look, you sooner or later you come across a small tool called gssproxy, which is not that much known in the world so far. And incidentally, that's my personal mission, to tell the world about it, tell that it is cool stuff and how to use it. Yeah, so this is the onset here. Who are we, by the way? I'm Daniel. I'm working on Kubernetes Keycloak mainly these days because something has to pay the bills, and also occasionally still on file system stuff, and I've also co-authored a book on Kerberos. Don't get too excited, it's written in German, so most of you probably won't be able to read it. And this is my former co-worker and good friend, Michael.
Yeah, that's it. I work for a company that's called science+computing. We do lots of HPC traditionally, and that's where we have lots of data on storage, which sometimes needs to be accessed using SMB or CIFS, as it was called. And that's where I came at this.
Yes, and me, I'm working for Puzzle ITC, a Swiss-based company, open source company, doing open source development and also caring about lots of types of open source technologies. And well, file systems is, dealing with file systems is something I support customers with occasionally when I'm not involved in the new fancy stuff with container platforms and authentication systems and stuff. So much for our own introduction. Now let's dive into the topic itself and what happens if we try to establish to use SMB mounts as a general purpose Linux file system, and what are the practical consequences that arise.
And the first thing you come across is that NFS has dodged one big problem traditionally by just not authenticating and just authorizing. It's called auth-sys, and it works very well, and it's used everywhere, and so everybody's used to it working that way. And SMB doesn't have that option. You have to authenticate at some point, and so using it as a drop-in replacement for NFS, you have to care about this, how to make it possible that it can authenticate. And also, NFS usually in the POSIX environment works with a static mount. It may be auto-mounted and other stuff like that, but usually it ends up as a single mount, and all users in the system use that mount to access the storage and access the remote server and the files on there. Again, traditionally, SMB has more likely lived in the user session, and connections were established as the user triggered that in some UI or something, and wasn't mounted into the file system hierarchy like that. But Linux does support that with the CIFS kernel module. And you would want to do that to get a really native interface. So we're not talking about GNOME VFS and user level sessions and stuff like that. We really usually want to do a mount. And then you don't want to have mounts for every single user accessing their files with their credentials and somehow supply them when doing the mount. You want to have a multi-user mount. And nowadays, luckily, the CIFS kernel module also supports that. You can do a multi-user mount. And then you basically have two options catering to the authentication part. Either you can push username and password down into the kernel. So then when at some later point in time, when an access actually happens and a connection needs to be established and authentication needs to be done, some credentials are present. You could even try to automate that using a PAM module, so it happens at login when the user logs in. But then you have to think about what happens when the user then has their session running, has other access running, the connection is somehow interrupted, and they've, in the meantime, changed their password, so they would need to be aware that they need to re-push the password down. And then, overall, it also only works with NTLM. And as we've just heard, I think 2 talks ago, we don't want to do NTLM anymore. So the other approach would be to use Kerberos. But that basically has the same problem. The kernel doing the access at some point in time needs to gain access to credentials for the user. And here it's solved a bit differently. Instead of pushing Kerberos tickets down into the kernel actually does an upcall, which throws up an interesting set of additional problems. But before we dig into that, we, I think, have a demo prepared where we just have a look what that feels like, actually.
As it happens, yeah, we just have a demo environment here, and yeah, I hope this size is okay. And also here. Okay, so what do we have here? We have 3 systems up that matter in this environment. We have an SMB client called LX01 running a version of RHEL 9 or CentOS 9, a relatively recent version. And then we have an LX02 which serves as the file server. It's running a version of Samba, but actually this doesn't matter here. The details don't matter too much. And both of these systems and also the file server itself, they're joined to an Active Directory domain. And yeah, that's essentially all you need to know about the environment. Then we have an SMB mount, a CIFS mount here from a home share on this LX02. It's mounted by the kernel. It's using the multi-user mount option and also Kerberos security. So we should be able to just log in interactively, supplying our password, obtain a Kerberos ticket automatically during login, and be thrown into our own home file system and just, yeah, be able to use it as we would expect from a traditional NFS mount. So let's see how this fares. And if I this time manage to clean up the demo environment correctly, as some arbitrary Active Directory user, I supply its password on the login prompt, and now that's boring. It just works, and which is great for you, of course. And actually, it's what we wanted to show. If you do it right, it just works right now. And yeah, we can see we can access the home file system. So this is really the SMB mount we just saw here. And we can also have a look and see that we've acquired a ticket granting ticket during login and also a service ticket for the CIFS service that was used to authenticate our access to the file service. So everything working as expected. Nothing to see here on an operational level. We're fine, and we're just waiting for Volker to get the POSIX extensions fully done. Or are we? And what actually happened here? So it looked really boring. Can we have a look at the magic that went on behind our backs.
So what happened here when logging in? Some process is launched, or when he launched a df, a command is launched that goes in with a syscall into the kernel, which goes through VFS layers and other stuff and finally ends up in cifs.ko. And cifs.ko, the access was delegated to it because it's a path that's coming from its file system it's managing, and it has to decide, can it access that resource? Does it need to open a new connection? And does that need authentication now? Because that might be quite involved, this open call is not only blocking, it's an uninterruptible sleep. So the process triggered by the user is really suspended from being interrupted and anything else, because a whole lot of other stuff then carries on. So in the case the connection is not yet established and there's no credentials available yet, and it needs to be authenticated, cifs.ko will call up to user space again, to a kernel, to a helper called cifs.upcall. That'll go looking for credentials for the user, for a ticket cache containing either already a service ticket for the SMB server it needs to authenticate to, or at least a ticket granting ticket it can acquire the service ticket with, and then it'll do that and finally establish a GSS context and push that down back into the kernel, and that can do the authentication to the server with that. So that's the easy part. The tricky part is actually finding the ticket cache. That's a heuristic, and that's a really complicated thing to do. The easy stuff, and I think one of the newer additions, is that everything the user is doing might be running in some namespaces. So it might be in a different file system namespaces, and their ticket caches might be just somewhere else on the host system, and they may have different paths inside the namespace. So cifs.upcall actually tries to enter the namespace of the triggering process. So we've triggered down into the kernel, called back up again, and then cifs.upcall knows the pit of the triggering process and changes into that namespace. And then it can try to apply some defaults and conventions to find a ticket cache. So there's a function it can call in the Kerberos library just to open the default ticket cache. But the user might not be using the default ticket cache. So the easiest thing they can do is set an environment variable, kerb5cc name, to override the path to their ticket cache. And cifs.upcall is catering to that as well as part of the heuristic. It's actually parsing the environment of the process via the proc file system and goes looking for this variable to see if that path has been overridden, to find the correct ticket cache. So this is quite an involved process, and there might be other corner cases as well. And so if it's not clear yet, it is fragile and brittle, and it can break. And I think Daniel has something prepared to show how it can break quite quickly.
Yeah, so let's apply just a small and seemingly unrelated change to this whole environment and see what goes on next. Sorry, let's do one step before that just to be sure. Let's throw away the credential cache. And then what we want to do now here is we just change the location of the default credential cache in the configuration file for the Kerberos library. So what we see here, this is Red Hat's default using the kernel keyring. And for debugging, what we like to do is just use MIT's default, which is a file-based cache, which is a bit easier to debug. And you can easily RM a file in /tmp, and it's easier to handle than the kernel keyring. So, and let's tell SSD that we've changed the configuration, make it pick up this new configuration.
Because SSD in this setup is doing the password-based login and actually initializing the ticket cache. And so it also constructs the path to the ticket cache where to put it. And perhaps setting environment variables and stuff.
Okay, so let's try the same thing as before, using a new user in this case, and see what's happening now. And oops, just a different C cache. or a different default for the C cache, and we try to enter our home directory, and we get slapped on our hands. SMB doesn't allow us to enter our home directory, or does it? Because let's try again. Let's just cd in our home directory again, and all of a sudden it works. And we see the credential cache was there. It looks like before we've got a ticket granting ticket. We again received our service ticket for the CIFS service, and yeah, what had been going on here? Why did it work before? And why was it so easy to break it with a seemingly unrelated change? So let's log out here again and maybe have a brief look at the log messages from the cifs.upcall. Oh, okay.
Can you just...
That's challenging. And maybe...
You can make it smaller.
Yeah.
Okay.
You're not that old yet.
If the letters are bigger than my head, they are too big.
Okay. And just need to find the right entry because I just logged out again, and that's the one where it was working. Okay, so this should be the right one. Actually, here you see a couple of the pieces of information in the first line that gets passed on from the kernel to the cifs.upcall. That's how it propagates information about the accessing process and the accessing user to user land. And this is unparsed here. And then the upcall actually tries to access the proc file system, proc pit, and extract the current setting of the kerb5cc name variable from the process's environment. And in this case, it just doesn't find it. At this moment in time during the login process, this variable just hadn't been set yet in the process, so the upcall fell back to using the internal default or kerb5's default value, which is just temp kerb5cc and the username as the only suffix. And if we look back here, that's almost the name of the credential cache, but not completely, because here in this case we got added a session-specific prefix, a random session-specific suffix, random suffix, and so I didn't show this here, but if you do the tracing, this credential cache had actually been there when the upcall went hunting, but the upcall just went looking at the wrong place because it couldn't extract the environment variable at this moment in time. And that's how this whole process broke, and that's what you'll have to debug if you were to implement this in a larger environment and maybe spread across different departments. And the admins there went coming to you and getting you to fix their stuff. Guess how I know. All right, so so much for this initial presentation. Summary, even though this upcall really implements a lot of magic and really tries hard to get it right, there are still some failure modes that are really non-obvious, and they can still break the whole process. So all of this is really fragile and brittle.
And if you thought this is hard, then that's not the actual problem yet, because we could continue to tweak cifs.upcall to get this heuristic more and more spot on, perhaps. But there's the principal problem with cifs creds as well as Kerberos, that credentials need to be available at an unforeseeable point in time in the future when an access actually happens.
Yeah. We didn't even talk about the hard problems yet. Yeah. Now we're talking about the hard problems.
Those are here. Obvious is if the user logs on without a password using an SSH ID, then there's the whole authentication part of the PAM stack isn't running, and so SSSD can't acquire a TGT in the first place. The user would have to forward that as well, but then they wouldn't be using an SSH ID anyway. They'd need to use kerberized SSH, which nobody uses. Then again, once they have their session running, they would keep it running as long as they like, and tickets do expire. So you would need to care about getting new tickets at some point in time. The user would need to explicitly have to run kinit for at least after a week or so to get a new ticket, to keep their home dir access working. Also, if you have set up cron jobs, or what I do a lot is HPC batch jobs, which run even on different nodes. Users submit them at one point, and they run at some completely other system. There will be no Kerberos tickets there for that user. And finally, you might have even obscure things like a session being terminated, credentials being actually intentionally be deleted so they don't get into the wrong hands, but some process still lingering around and wanting to shut down some other stuff which needs access to some storage. So this is a fundamental problem with this, that you have a time component, and you will have users who just aren't there to provide credentials. And with CIFS creds, we don't have much of an idea how to get around this, but with Kerberos, we have a standardized protocol with lots of extensions and history. So we could look into its toolbox to see what it does provide to perhaps deal with the problem head on, or even better, completely sidestep it. And what's in there in this toolbox is impersonation and delegation in various extensions, which allow a kerberized system, a service, to instead of authenticating the individual user and providing credentials for the user, authenticate itself, prove its own identity, and then impersonate users and act on their behalf. And that would allow, if we were to configure that for an SMB client, allow that SMB client to impersonate those users and access their storage on their behalf, and would not require, in the case of the extension called protocol transition, any actual cooperation of the user. It would be possible at any point in time without the user being present. Obviously, because you're then trusting the system to behave correctly and not abuse this, you would, to lessen the attack surface, to minimize it, ideally limit that to a selected set of resources those user jobs actually need access to, which is possible with protocol transition, where you can have a list of services you've actually allowed impersonation for. And then it's also implemented in numerous Kerberos implementations, most notably Active Directory, and then also sambaXP. And using all of that, you eventually end up with a system that feels like NFS with auth.sys. You don't see any authentication happening, but in contrast to NFS with auth.sys, there is authentication still happening, just not of the individual users. They don't have to provide tickets and passwords and stuff, but the system will authenticate to the Kerberos KDC, and it'll be logged there. It's auditable. You can see in the configuration of the KDC that this is allowed, and which systems you have allowed this to, delegated this to, this permission to do this kind of stuff, and even actually exclude some perhaps sensitive users from this impersonation.
It's a trade-off, basically, between security and usability. Yeah. And also, given that we're in a room full of Samba developers, we need to add that this is not the only system that can do impersonation. There's also an alternative within the SMB3 specs called Remoted Identity Tree Connect, which is essentially impersonation at the SMB level. And it needs support on the service side, on the SMB side. So I can appreciate this might be appealing to some of you. However, the solution within the authentication layer within Kerberos itself, it's certainly more generic, and it also works without requiring support from the individual services. Okay, so within Active Directory, if we want to use impersonation or delegation, as Microsoft prefers to call it, there are mainly two ways. The old way, so to speak, the old way of configuring protocol transition. And let's not get bogged down in the details of how this is done. the slides are intentionally verbose if you want to read it up later on, or maybe you know anyway. The crucial difference is the old way of configuring protocol transition. It's configured on the Active Directory object representing the SMB client, and also comes with a couple of restrictions, like being confined to a single domain only, and yeah, the good thing is it also works with older Kerberos libraries, but then this way of configuration is a little bit backwards, because essentially the administrator of the client side grants itself extra privileges to access resources on the file server side, which wouldn't be there natively. So that's why there's a new thing called relatively new thing called Resource-based Constrained Delegation, which turns the configuration part on its head and lets the server side, the service side, their admins configure who is allowed to use impersonation when accessing their services. This is also supported within Samba since 4.17 if you use the MIT library, Kerberos library, or 4.19 with Heimdall. Yeah, and this also can work across within a forest of multiple trusted domains. Okay, the downside is it requires a bit more tooling to configure, because it's configured as a security descriptor, which is a binary blob within LDAP, and it's not easy to construct this security descriptor. It requires additional tooling.
And also, the original constraint delegation requires configuration on every single client object, which would usually be the computer object. And this is quite annoying for AD admins, because they have to then, when you join a machine, go there and put these delegation permissions on there, which might prompt workarounds, like instead of using the computer object, have a service user and give permissions to that once, and then use that on all your SMB clients, but then again you have a single point of failure with that single user, so that resource-based constrained delegation approach is much more appealing, basically. Because you have a single source of truth, you have one object, and you just have to go there and you see all the delegation that's allowed, and you can just add one more and be done with it. Sorry.
No, go ahead. So
yeah,
what to do if we want to use impersonation on a Linux system?
Exactly. So we've been talking about how a cifs.upcall deals with the upcall from the kernel and tries to find a ticket cache. And now with delegation, we don't need to find a ticket cache anymore. What we need to do is just get our stuff. So we need to have our machine identity, authenticate with that, and then impersonate the user. And we could do that in cifs.upcall and extend that a bit with a few library calls, and that will certainly work. But then again, there is already a component doing all that, which is called gssproxy, as Daniel already hinted. And we just need to make cifs.upcall able to leverage that, access it, and have it do all that for it. And the only caveat with that was that cifs.upcall used the low-level libcurb5 libraries until recently, and sort of did everything itself, and didn't even use the GSSAPI layer. But that's been changed with a small patch, and now it's at least using that as a fallback. So if it can't find the ticket cache, using its heuristic, it'll fall back to GSSAPI and just trigger that API, which then goes off and works through its module configuration, and one of those modules can be our gssproxy. And
that's what we'll show now.
Exactly.
When was it changed? In what kernel version?
No, that's not actually kernel. The kernel just still does its upcall, and you need cifs-util 7.0. And that needs, we'll have that, we'll do that now. It needs an environment variable set to enable gssproxy as well.
Yeah, so there are basically 3 steps you need to take to configure your system for impersonation. And the first one is to configure the cifs.upcall, which is in etc request key.d, and the related configuration file. I already prepared this. So this is what you'll see natively, what your distribution or the CIFS utils usually will ship. And let's change this line to this one. So all this does is it sets an extra environment variable gssproxy equals yes when calling this cifs.upcall, and that's it. So this is how you tell the upcall or the GSSAPI library to call into the GSS proxy when going hunting for tickets on the system. All right, then the next thing is we need to tell GSS proxy that we want to use impersonation. Here's a generic configuration file also shipped with your distribution usually for GSS proxy that is used by all processes running as the root user. Usually this is the file system clients. And here we tell them to use impersonation. Impersonate true, I think it was. Is it yes or is it true?
All the
I
others
think both
yes.
work. Impersonate. So
the man page would know.
Let's restart the GSS proxy. And so our client is prepared to do impersonation. And the only missing piece is consent from the file system administrators to allow us to use impersonation on our client. And so we need to configure resource-based constrained delegation on the Active Directory object representing the file server and allow our client to use impersonation. And there we can use Samba tool delegation. Let's first look at the current configuration for our file server.
Can you put that up top?
Oops.
Daniel?
Yep.
Yeah.
This might be a bit better to read. Okay, so currently there's no delegation configured for this server. So we say add principal and no, that's wrong way around, or is it? No, it's like this. Got it right the first time and didn't trust myself. Now we got it. Okay, so now we're allowed to use resource-based constrained delegation, and GSS proxy should be able to obtain CIFS, CIFS service tickets for arbitrary users on our system. So,
One moment. This is in a security descriptor because you said you have to establish a security descriptor.
yeah, so what this command actually changes, it sets a field in LDAP, an attribute, and this attribute contains an NT security descriptor, which is a bit of an odd way to configure this because there's only one variable piece in this security descriptor, and that's the SID representing the client. So you set a security descriptor, which is a list of individual ACEs, and these ACEs all use exactly the same form, except so the same privileges, the same allow directive, and the only variable piece that changes between individual entries is the SID. Why they didn't just allow to configure the SID itself as a multi-valued attribute in LDAP, I don't know. Maybe they have bigger plans, but this is the reason why it's a bit cumbersome to set this configuration option, and why you need a tool like the Samba tool add principal to do this. and just can't construct a simple LDIF by yourself.
And also to make it very clear, at least to my understanding, he's the expert on that, this security descriptor doesn't appear anywhere in the protocol. It's just a configuration of the KDC. So we're just configuring our KDC to accept requests for impersonation. And it could be configured anyway. It could be a text file. It could be in the registry. It's just a way of configuring it. So they put it into LDAP and they put it into a strange format. Okay?
Is the server here Windows AD or sambaXP?
It happens to be a Windows Active Directory, but the same, I don't have it up and running here, but the same works with Samba since 4.19 if you're using a Heimdall, or 4.17 using MIT. Okay, so remember this is still the system that used to be broken before. We didn't apply any changes on that level, so we're still using MIT's default cache, Zcache template. And now let's try to log in again as a new user to avoid any undesirable consequences and not mistype the password. And we see all of a sudden it's working again. We're able to log in even though cifs.upcall wouldn't be able to natively obtain a direct credential for this user. And we see, well, the TGT is still there. We've logged in using a password, just conventional login that used to work before as well. But it's only the TGT, the CIFS service principal, the service ticket itself, it was acquired by gssproxy for us. And so the fact that we have that we even do have a TGT at our disposal here is irrelevant to us being able to access our SMB home file system. And so this also means, in this case, we'd be able to just use SSH key-based login, for example, or anything non-interactive where we don't supply our password itself in clear text or by some other tricks like a key tab, and we'd still be able to use this system just normally, as we'd expect.
Mm-hmm.
Pardon me?
Can you try SU- from root?
Yes, sure.
So any bets on what's going to happen? Who thinks we get an error? Who thinks it'll work? Okay, yeah. So
Here we go.
okay, because again, the system can open a session as the user. It won't have any credentials, but gssproxy just goes ahead and impersonates that user towards that server, and access is possible. So we are basically back to standard Unix root semantics, where root can just impersonate anyone. We have to trust root, but we don't have to trust our machines based on their IP address. And so anybody can just plug in their laptop into our network. It at least has to be a joint machine that has to have these special impersonation credentials.
And that's an SSSD join right now?
Yeah.
Does it also work with WinBind?
Yeah. You have a computer object, you have a local key tab file for SSSD to authenticate or to do the basic AD join, and gssproxy uses that same key tab file to acquire credentials. And as it happens, we have a slide that looks amazingly familiar to what we did before. But now we've introduced GSSproxy, and the cifs.upcall isn't hunting for any ticket caches anymore. It just outsources the whole problem to GSSproxy. And that could go hunting for credentials as well. There's loads of more stuff you can do with GSSproxy. It could not, instead of impersonating the user, it could actually have the credentials of the user, and we could basically give it the password of, not the password, a key tab file, but essentially the password of the user, and then it just would acquire the TGT of the user. And other cool stuff for local users, for service users you can do, but here in this case, it authenticated itself as the machine, using its identity client $@domain, and had its impersonation privileges, could acquire the service ticket, pass that back to cifs.upcall, it could pass it down into the kernel, and everything worked just fine. But we still have to do the namespace dance, right? So at least the user process could be running in the namespace, the gssproxy as well. But yeah, that's, I think, basically what we wanted to show. Time for recap, right?
Time to summarize. And what are our key takeaways from the session? And first of all, I hope you've seen that using gssproxy is really easy. It's just a few steps and you have all this power at your disposal just now. The development work is done. And also, in general, you've also seen that when you want to use SMB as a general purpose file system on Linux, even if feature-wise everything is there and implemented, there are still pitfalls because of the way authentication needs to be integrated within the system. And when you're confined to just POSIX semantics when accessing the file system, there's just no notion of supplying GSSAPI context or some other form of network credential directly with the system call, and there's some magic involved in any case to obtain these credentials. So if you try this, and this is sort of spoken from experience, not necessarily with SMB, but mostly with NFS-related projects where we run into the same problems, or most of these problems as well. At some point in practical environments, you'll hit a wall and will run into problems that are impossible to solve just with basic methods of authentication, and there gssproxy really is the solution and offers a way out and gives an option to trade optimal security against optimal usability. And so it's really a crucial ingredient. And all of this really relies on the fact that cifs.upcall was changed to include GSSAPI support and is not limited to just using basic libkerb5 calls directly. Yeah, so that's all the magic that was needed. And
then also, what I might add, what you could actually argue, GSSAPI support in cifs.upcall is fine. It's a fallback right now. The native libkerb5 heuristic is the default still, and the fallback to GSSAPI only kicks in if no ticket cache can't be found using the traditional method. You could even argue, we've been arguing amongst ourselves, if you should continue to tweak this heuristic at all, or if it would perhaps even be better to just consign to the problem that it's not solvable and perhaps switch it around. Make the traditional method the fallback for traditional or legacy users, and make GSSAPI the default, and just be done with looking for environment variables altogether, and just say, okay, if you have a complex environment, you have to run the long-standing established convention defaults anyway, otherwise it'll break at some point. So we can just go with GSSAPI as a default. It'll do most of what the native mechanism does as well, and makes it even easier to then plug in something like GSSAPI, gssproxy.
Yeah, I think this is a good topic to continue this evening, maybe. Also, given the fact that local KDC also has the same requirement as it happens, and also requires stronger GSSAPI support in this upcall. And also, it's kind of strange that they chose to use libkerb5 as the implementation library when all they need in the end is a GSSAPI context. And there's a library for that is just there to provide this type of context. So I found it a bit strange when reading through the code. But anyway, let's close this discussion for here. And really, the main takeaway from my opinion is that there's no need to use gssproxy with all the SMB mounts, but I think it's an absolute must to know what gssproxy is, what it does, and how you can use it. That's it for now, and thank you.
Thanks. Any questions?